There we go. Greetings. I'd like to give you a bit of an update on the NSI Registry and the gTLD program. And Mark will come up and talk about the Root gTLD stats and some of the next generation work we're doing. Yes. Is it better? Anyway, for those of you that aren't familiar, the NSI Registry split off from the NSI Registrar internally. There are two different organizations. Mark and I are going to be talking about the NSI Registry, and we actually work on the NSI Registry side. The actual registry began operations in April. Fundamentally, the core system consists of a database that provides real-time access to registrars via the Registrar Registry Protocol, RRP, that allows registrars to check for domain name availability, to add, modify, delete, and transfer domain names, as well as pull back status from the database. This protocol is an internet draft now, and if you're interested in looking at the detailed spec, you can go to the ITF site. The actual draft is, I believe, draft-hollenbach-rrp-01.txt. And that will give you a lot of detail about the RRP spec. Anyway, the registrars connect to the database via RRP over an encrypted SSL session and can check for and provision domain names. We went live with the system beginning with NSI Registrar in April. We went through a rather extensive cutover process where we ran both systems, the existing internic and the new registry systems live, or actually we brought up the registry system next to the internic system, then switched over and ran the registry system live, continuing to cut zone files from both and whois and checking everything, and then finally going fully live just before, or in April, early May. June saw our first non-NSI registrar, and by August of 1999, to provide a quick snapshot, we had 8 live registrars accessing the system, and at that time, the read-write traffic that creates, updates, deletes, and then transfers averaged about 132,000 a day. Not a lot of load, 3 to 4 operations per second during busy hour. Our read-only query loads, which include both the check operation, which if you go to pretty much any registrar's website and check for a domain name, it'll come back directly to our database in real time to see if it's available. Averaged about 1.3 million operations a day. Around 30 to 35, 40, 45 operations per second during peak times. If you look at today's numbers as of last week, we have over 25, just about 30 registrars in production live. Our average daily read-write-create loads about 250,000. We've seen peaks about 500,000 or so. Translates to 6 to 10 operations per second. The read-only query loads have really gone up. Our peak is about 6 million. We average about 5.2 million a day, and over a 300% increase. We see, on average, during busy hour, 140 to 150 operations per second. We've seen peaks at over 200, and that's into a live Oracle database. Anyway, in terms of some of the things we're going to be focusing on over the next year, the primary emphasis really is hardening the core, delivering a dial tone-like quality of service. Given that we're an e-commerce wholesaler effectively servicing all the registrars, our customers, the registrars, can only be less available and perform less well than we do, since they have to come back to us. One of the key initiatives that we're in the midst of right now is putting up a full-on hot secondary site. Rather than just a disaster recovery, sort of business continuance plan. This will allow registrars to stay connected. Ultimately, when we finally finish the implementation, allow registrars to stay connected during a failover and allow us to basically convert maintenance windows into just failovers from one data center to the other. We're also looking at scaling the platform by allowing a separation of read-only from update, create, delete operations, as well as prioritizing operations to allow checks and adds to have priority, and also allowing, or actually stopping registrars from taking all the bandwidth during peak times. So we've had some situations where registrars maybe changed some business policies or trying to do, taking a different approach to how they're actually accessing the system, and they'll consume a fair bit of the bandwidth, not the actual network bandwidth, but the database bandwidth in the system. So we're doing some things to make sure that it appears as a virtual individual system to each one of the registrars. We're also doing a fair bit of enhancements to the tools and a little bit to the RFP protocol. The other part to this is we've been focusing a fair bit on the engineering processes. Availability with the kind of numbers we're looking at, as well as performance, requires sort of an end-to-end approach to this. As a simple example, with the .dot domains that came up a couple of weeks ago, last month, we actually found out about it on I guess it was a Saturday evening. We had the fix in production. We had the fix out of development Sunday evening. It was fully tested, regression tested Monday morning by 10:30 and in production by 12:30. So that's some of the stuff that we've been working on in terms of repeatability. The other side to it is we've heard from our registrars that they want 30 days notice in terms of any sort of downtime that we have from planned outages, upgrades, so that they can make their planned downtimes coincide with ours, so they don't have to take yet another outage for their own issues. So we've been trying to put in place a fair number of processes, the usual one-on-one stuff, so that we can do that kind of planning. And if any of you have been into software development, you know how hard it is sometimes to hit these deadlines dead on. But anyway, in terms of in terms of the gTLD program, we put out an RFP about a month and a half, almost 2 months ago. The whole objective of it was to basically place the gTLD and root servers at the topological cores of the internet. We wanted them basically to be as close to folks using them as possible. We also wanted to bring some service level agreements to support the whole infrastructure. I mean, it's a critical infrastructure. We want to make sure that we have in place the right type of service levels to continue to support this. We looked at a bunch of different criteria in terms of evaluating the responses we got, including proximity, internet connectivity, peering relationships, the various facilities, and technical support, and also price. Of the 80 that we distributed, requests for proposals, 28 vendors registered to provide a response, and 20 actually did respond. Right now, we're currently in the last stages of evaluating those proposals. We've done some site visits, and we'll do a couple more. And before the end of this month, we'll actually put out the list of selected vendors. The schedule is to begin the deployment of the gTLD platform starting in this month and conclude by the end of July. We're trying to allow enough headroom in this so that we can bring up the infrastructure, make sure everything's right, run some things in parallel long before we have any 32-bit issues. And Mark will talk about those in a minute or two. Mark?
Is this thing on? Hello? Yeah. Okay. Okay, can you all hear me fine? Okay, great. No. Hello. Okay, I'll just do this. Growth in comms, of course, accelerating, and with the advent of the Registrar and Registry Split, it's actually even accelerated more. And this is really essentially putting our resources to the limits. For example, one of the things that the other root and gTLD servers did in the past was be able to zone transfer off of A. And that's really no longer possible. As you know, bind is a single-threaded process, and now when A is so busy trying to answer queries that when it does a zone transfer, it starts dropping packets like a banshee. And we certainly don't want that to happen. It's on a fairly large piece of gear, too, getting ready, preparing for bind version 9. With multiple CPUs, but until it's fully vetted, we're going to stick with 8X series. Okay, another problem too is zone propagation, and this is especially true for things that are on either side of the pond. We have a site in London that we've had some problems with getting zone transfers to, as well as we have a site that at some point will go live that's in Hong Kong, and that also has some problems with propagation. And of course, queries per second is growing. So here's one of these graphs I show almost at every NANOG, and it's average queries per second for a root-servers.net, which is a root server and also a gTLD server, j.root-servers.net. Sorry, you're going to have to kind of like look at these things and extrapolate a little bit, which is a root-only server and only serves dot, and j.gTLD, which serves ComNet and org. And as you can see, they kind of bounce all over the place, but it's typically on the growth curve like you all see. Usually these things you can wow and amaze your girlfriends and significant others. For my wife, it puts her to sleep. Okay, now here's some interesting stats I haven't shown before in terms of what sorts of queries hit A. What types of traffic does it see? And it should be no surprise that A queries are certainly the most prevalent type, followed by PTR with 17%, MX with 6%, and any going down to 4%, and then the rest are kind of down in the noise. One of the interesting ones is type 33 queries. I have no idea what that is. It's probably Microsoft. Okay, here's top 10 root.servers.net queries, which is a dot-only server. And of course, it's very similar, and it has about the rough same sort of mix with A queries, PTR queries, MX queries, and so on. What's interesting about this one is quad A queries, actually, they're just a little bit off there on the right-hand side. So maybe IPv6 may happen. And here is j.gTLD servers.net, which only handles gTLD's ComNet and org. And as you can see, A queries are like the big thing. And of course, there's no PTR types, or very little. Someone must have really messed up there. Okay, one of our big things is with all this growth is, okay, how are we going to handle these things working in a 32-bit OS? Because as you know, a 32-bit OS, a image can only handle 4 gig. That's the maximum that any 32-bit OS can handle to run a process. And we've been doing some extrapolation of that and saying, okay, when will this thing die? And this graph isn't quite right, where it shows August 2000 as being the 32-bit memory wall, where you have to go to a 64-bit OS. It's off to the right somewhat, but not a lot. Right now, we've done some tests internally and been able to show that we can handle about 20 million delegations for COM on a machine in a reasonable manner. We're currently at 12. So the time is quickly coming to where there's going to be a paradigm shift, not only with how things are served, everything in memory. By 9 is going to help solve that. But also with 32-bit OS actually being able to serve this sort of data. Okay, here's average queries per second for A. And actually you can see that the growth trend is just growing. It's just another variant of what we were doing earlier. Same with J. Yeah, it's a straight line. And j.gTLD. Okay. One of the other things that we're trying to do is trying to solve the problem of being able to propagate these zones in remote locations. And we're kind of experimenting with doing some alternative means of getting files from here to there. And one of the things that's looking perhaps kind of promising is satellite-based zone transfer distribution. And we can do some other things like compress the zone files. So we can actually put it there in a much smaller size. So right now, zone transfer is about 1.4 gig with COM in its present state. They're growing exponentially, and there's going to be soon some problems with some of the other server operators I need to talk to you about handling files over 2 gig. Sun has some problems with that, and there's some things you have to do in compile time options, and you have to muck with the code a little bit in bind to actually fix it, but we can do that. Now with the latency and congestion over the internet getting to these sites, there's been all sorts of access problems like I mentioned earlier. 4 hours for Hong Kong, for example. And with the frequency of zone file distribution, this is going to start being problematic with releasing something in Herndon, but yet the zone transfer going on in Hong Kong has not completed yet for the previous day. So you get in some really nasty sort of scenarios. So we're thinking about doing satellite. And if you compress it, you get about 120 megabytes for COM from 1.4 gig. So you can see that zone compressing it helps. And one of the things that we like about doing satellite is that we'll get perhaps some fixed latency and congestion-free sort of transport, and be able to transport these zones at these various locations in a reasonable time, and about approximately the same amount of time, at the same time. And it will cost less load on the zone distribution servers. Right now we're using basically hidden distribution servers to propagate these zones to the publicly accessible zone servers today. And we'll be able to hopefully do some more frequent zone updates. Now, here's a timeline, and frankly, this thing is not fully vetted yet, so I wouldn't put a lot of faith in this. If things were in a utopian society, this might be true. There's a lot of things that we got to look at and be able to make sure it works, and we're just barely starting to delve into this. But if it does work out well, this would be like best case scenario, being able to put this thing out in, say, end of May. So now I'm going to kind of switch gears a little bit and talk about DNS security, since that's kind of getting some more visibility now. Been able to participate in a number of workshops in Sweden and the U.S. And one of the things that's resulted in this is that these things are non-trivial setup, and it's kind of complex. And it doesn't help that the current implementation is really buggy. And in that the Bind 8X series, yeah, sure, it can go ahead and display your keys and show your SIGs and be able to do NXT records, but actually being able to verify these things is not so easy. And so one of the things that's going to come up, for example, is being able to, it's going to do no longer will you be able to, if things go to DNSSEC world, no longer will you be able to get a NS query for DOT with DNSSEC enabled servers within a 512 byte, 12K byte limitation for bind. So this is only going to work in an eDNS aware server. And so in Bind 8X series just is not going to work for this. So we got to look at Bind 9 before DNSSEC actually comes even close to implementation. So one of the things that this means is, okay, if this does happen, how's all this going to work with this registrar registry split? Well, what's going to happen is you, as clients, will go talk to your respective registrar and authenticate through them. And once they have authenticated you, they will in turn you will give them your key. They will then authenticate with the registry with their password or whatever, and and the registry will say, okay, did this domain actually come from this particular registrar? Is that registrar valid to do authorized to do anything with this? And if so, sign it, and it will be passed back to the originator. So this is our current proposal. One of the things that you're going to have to do is, at this point in time, key rollover is a problem, so this is something that you would have to do on at least a monthly basis of re-signing your public key with a new key set from the gTLD operator. Okay, now things that are issues, of course, is that the registrars need to set up a front end for a signing service. The RFP needs to be updated to allow for keys to be signed through the process. There's some performance issues. Signing is a non-trivial sort of deal, and security issues with key visibility is certainly something that we need to look at, as well as protection of the private key behind the scenes. So, and here's our contact information if you'd like to know anything further. So, lights up. Any questions?
Brian Blank with T-Row Price Information Technologies. I was wondering if there's anything besides the SSL authentication going between the various registrars.
There's SSL v3 between the registrars and the registry, and then within the RFP session, there's also a password, user ID password authentication.
Thank you.
Sean Donlan. Actually, I'm hoping Bill Manning's in the room because this is probably more from him. Choosing the locations on the network to put these particular servers is always an interesting issue because the network tends to be organic and grows to wherever the servers are put. As we even saw with NSI, I mean, we can remember the days of them with their T1 line in 1992 or whatever. So how are you trying to decide where to put these servers when the network will change depending on where you put the servers? And if Bill's around, I would be interested in his research on that too.
I actually don't see Bill, but I can somewhat speak for the root server operators as well. And one of the things that the root server operators are doing right now in conjunction with CADA is to run Skitter to find out how close our various sites are today to the various endpoints that are querying us. Now, one of the things that I don't know is how many people have engineered their networks to get closer to the root servers. And as you spread these things out, is they're going to be in sort of re-engineering to put them closer to this or that as they move.
Okay, so you're using Skitter?
Skitter is the tool that we're using for the root server operators.
Okay.